Hello, grade 8s. How are we doing today? I have a guest in today, so I thought I'd just put together a quick little lesson for you. First of all, this should be the handout in front of you. If my guest teacher hasn't handed this out yet, maybe he or she could just hit pause on the screen and quickly pass those out. Now that we've got them all, let's take a quick look at it. Square roots of what we've been talking about for the last few days. Square roots can be represented with square models, number lines, and mathematical symbols. Let's start with the symbols and our calculators. A perfect square is the product, that's supposed to be say, of two equal natural numbers. For example, 25 is a perfect square. And we've spent a little bit of time over the last few days talking about what a perfect square is. With the square root, 5. So the square root of 25 is 5. We write 5 squared equals 25, and the square root of 25 equals 5. To find the square root of a number with a calculator, of course, you use the button or the key that has a square root symbol on it. To find the square of a number in your calculator, you use the button that has an x squared on it. Those of you who have one of these TI-30 calculators, your square button is here and your square root button is here. There is the odd student who might have a fancy calculator where in fact they're the exact same button. If that's your case, you're going to have to actually get to squared by using this key over here that says shift or second function. Also, the way you type it in is going to be a little different. If this is your type of calculator here and you would like to square root the number 16, which we know already should be 4, you actually have to type in 16 and then hit your square root button. If, however, this is your calculator, you will likely have to type it in as the square root first of 16. Give that a try right now if you haven't done so before this, and see which way your calculator works. I'll give you a second. Seconds up. All right, let's do one of these. We talked about this last class, but we never actually wrote it down. In the space that you have at the bottom of the page under example 1, please copy down this little example. If I would like to use square tiles to find the square root of 25, all I have to do is draw, and please draw this nice and carefully. I know you're not as great an artist as I am, but, do your best. Draw yourself a square that's made up of, in fact, 25 square tiles. Yes, all these tiles are exactly the same. They have the exact same length and width. They're all squares. Can't you tell? Aren't they lovely? So there we go. Altogether, that's 25. The square root of 25 is equal to how long each side of a square with area 25 is. So obviously the square root of 25 is equal to 5, because this thing is 5 units this way by 5 units that way. Pretty simple. Give you a sec to maybe sketch that diagram down and catch up to me. Seconds up. Now comes a tougher example. I want to use a square model to estimate the square root of 56. Now 56, you'll recall, is not a perfect square number. Remember, my perfect square is 1, 4, 9, 16, 25, 36, 49, and then after 49 it's 64. 56 would be between those. This number, of course, is 7 times 7. This number, of course, is 8 times 8. So 56 is not 7 times 7, nor is it, that's the ugliest 8 I ever made. I'm going to fix that. Nor is it 8 times 8. So it's some sort of number between 7 and 8, and we're going to figure out what that number is, or estimate it, again using a square model. So I'm imagining the closest I can make to a square is to use 49. So once again, I'm drawing myself 1, 2, 3, 4, 5. Oh, that's terrible. I'm going to try again. I'm going to start again. Sorry about that. Much nicer. little skinny at the top, maybe. There we go. A 49 square, because it's 7 units long by 7 units wide. So that uses up 49 of my tiles. Problem is, I have 56 tiles. So what am I going to do? Well, 56 minus 49 is, in fact, 7. So I will have a row of 7 tiles left over. Now, luckily for me, this row is, in fact, the same length as the previous row, or as the entire diagram, I should say. So I'm going to imagine I take a pair of scissors. That's how I draw scissors. And cut this in half. And when I do that, I'll have 2 halves. I'm going to stick one of the halves up here. And I'll stick the other half. Stick the other half over here. Oh, that should go over a little. There we go. See what we've done to our diagram now? Now our diagram is 7.5 units across to get to there, and 7.5 units long to get to here. Again, I'll give you a second to draw me a picture that's 7.5 by 7.5. And when you do that, make sure that you leave that little bit of empty space there, because there would, in fact, be some empty space there. And as you can see, that proves to you that the square root of 56 is not exactly 7.5, because there's a little bit of space missing in order to try to make a perfect square out of it. So that tells me, in fact, that the square root of 56 is a little bit less than 7.5. So my estimate is going to be that it's, oh, I don't know, maybe so close to 7.5 that I'll say the estimate's 7.5. But in fact, I know it's going to be 7.4 something. That something's probably bigger than 5, so this will, in fact, round up to 7.5. Let's see if that's correct by using the calculator. Calculator. So let's see. 56 square rooted. Yep, look at that. 7.48. Perfect. So 7.5 is a perfectly good estimate for the square root of 56. Again, I'll give you a sec to get this lovely diagram down on the page. I get kind of bored while you're drawing. Okay, time's up. If you need more time, ask my guest teacher to pause the video. Last one. What if we wanted to estimate a square root not by using a box, but by using an actual number line? Let's take a look at what that looks like. We would like to estimate the square root of 12. Well, we know that 12 is somewhere between the square roots of 9, and then that would be then the square root of 10. That'd be the square root of 11. There's what I'm looking for, the square root of 12. This is the square root of 13. This is the square root of 14. This is the square root of 15. Oops. This is me making my picture bigger because I didn't draw far enough. And this right here is the square root of 16. Now, why did I draw those two down there? What's special about them? Well, those ones are, in fact, whole numbers. The square root of 9 is 3. The square root of 16 is 4. So the square root of 12 is somewhere between 3 and 4. And this number line's giving me a nice estimate, but it's giving it to me as a fraction. If you counted how many spaces it takes to make one whole thing, it would take 1, 2, 3, 4, 5, 6, 7. So I have 1, 2, 3, 4, 5, 6, 7 pieces that make one whole thing. You've seen stuff like that before. Imagine a pizza that you cut into 7 pieces. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. You would say that if you had one of those pieces of pizza, you have 1/7. And this is, in fact, the exact same idea. I'm going to try drawing a light bulb. Idea. Exact same thing. If I've split a whole number into 1, 2, 3, 4, 5, 6, 7 pieces, then they are in sevenths. So the square root of 12, which lives right here on this number line, is 3 and 1, 2, 3/7. That's going to be my estimate. Give you a second to catch up to that on the diagram. Seconds up. And like I always do, oops, didn't want to do that. Hang on. Sorry about that. Where'd my calculator go? There he is. Let's see how close we are. 3/7. Did you know that you can turn any fraction into a decimal by just dividing it? Is 3 point, come back, 428,571. 428,571. And then it's repeating. It actually goes on forever repeating. So that's what that is. So how close is that as an estimate to the square root of 12? Let's take a look. Square root of 12, 12 square rooted, is 3.464. So the actual number is 3.464. So it's a very good estimate. It is in fact off by 4/100ths. Pretty darn close. So the square root of 12, I would say, is approximately 3.4. Or if you like, just say according to my number line, it's approximately 3 3/7. Ta-da! So there you go. That is the two ways that we're going to estimate square roots using pictures. Of course, I also told you yesterday that if you can just imagine in your head that 12 is about halfway between 9 and 16, therefore in your head you think it's about 3.5, well, hey, look at that. You actually got a better estimate than I did with my fancy number line. So there's nothing wrong with just saying, well, it's about 3.5. When you estimate these things, if you're off by 1/10, what do I care? After all, it's just an estimate. No big deal. Now, there's people who freak out when they look at this number line thing because they think, last time I looked at my metric ruler, anytime I go between whole numbers, there's always 10 things. That's why the first place is 1/10, the second place is 2/10, the third place is 3/10. What's going on with this 7ths? Well, keep in mind, the metric system is built on the idea that between all whole amounts is 10 smaller measurements. But you don't have to count things that way. Ever turn your ruler upside down and use the non-metric side? Whoa. Close enough. If you ever looked at the non-metric or imperial side of your ruler, well, there's the distance between one whole object, 11 and 12. That's a heck of a lot more than 10 things, isn't it? In fact, these things here would be half things. These guys right here would be quarter things. That makes these guys here 1/8 things. These guys here then are 16th things. And these itty bitty one here are 32nd things. If you really wanted to count them, all the little ticks all the way, there is in fact 32 of them. So they've actually split the ruler into 32nds of an inch, which if you've ever done carpentry, you know that this is in fact exactly what carpenters measure in. They don't, almost never do they measure in decimals of an inch. They go to 1/2 inches, 1/4 inches, 1/8 of an inch, 1/16 of an inch, and 32nds of an inch. So it's not an unusual thing to take a number line and split it into units that aren't necessarily tens. Just thought I'd point that out in case people are looking at this number line going, what? Number lines can't do that. They have to be tenths. No, they don't. They can look like this. All right, for the rest of maybe this period and some of the next period, since, my God, you guys have a triple, we'll get you to work on that booklet that my guest teacher has handed out. If anybody finishes it, I'll actually have her put down on the board what the next textbook assignment is if you want to get ahead on that. And maybe later on, I'll get a couple of videos up that she can click for you that are kind of cool that have to do with squares and square roots and exponentiation and things like that. And you can watch a few minutes of videos. Anyway, I'll come up with due dates for this booklet when I get back tomorrow. Remember, for tomorrow, you were already supposed to be done some of the stuff from the textbook. I was supposed to homework check it today, but of course I'm not here. Let's see. What does it say on my homework online? Let's see. Oh, that's too big. Too big. Too big. I only wanted 200, not 400. There we go. Let's see. Where are you? 8.5. There you are. Yeah. You were actually supposed to be done this assignment here, page 15, 5 to 7, 10, 11, 13, 15, 21, 22, and it was supposed to be due today, but I will not be homework checking it until tomorrow. So if there's anybody who needs a few minutes to finish off that, maybe you better do that first. Otherwise, do as much as you can in this booklet here that I've just handed out to you, and then we'll get some videos on a little later. Thank you very much. Have a good rest of your day.